Okay, now let me explain some basics of SPEDAS, including tplot command, also tplot variable, which is important when you're using SPEDAS. Okay, but before going into detail, let me explain some command line tips for IDL and also typical errors which you would encounter. Okay, first you have to insert comma between commands and arguments and keyword in any IDL command lines. For example, here tplot is command, so 1 is arguments, and title equals new plot is a keyword. Then you have to put comma here and also here again to separate command, arguments, and a keyword. Okay, and if you express a character string on IDL keyword, IDL command line, then you have to put single quotation before and just after the character string, like here. But you can put double quotation too to express a string. And also you can make a numerical array and also string array on IDL, but in that case you have to bracket numerical arrays like this, and also you have to bracket string array, but each string element should be sandwiched with the single quotations as I mentioned. And also if you are using IDL command line, then you would encounter various errors on IDL, but here let me explain two of most often encounters errors for beginners. First is attempt to call undefined procedure blah blah blah. If you encounter these errors, in most cases the command or routine names you would just typed is misspelled, so you have to check the spelling of the command name or routine name that you just typed. And also you might encounter syntax errors. Of course, syntax error means various things, but in most cases you would mistyping comma or single quotation, or either parentheses or brackets is missing or mismatched. Okay, so you have to check the matching of brackets or parentheses, and also you would find missing comma or single quotations. And you don't have to retype entire command when you would mistyped. You can just click up arrow key to reuse the previously typed commands. So previous typed commands just appears as the current command line prompt. And also you can even edit those commands by typing left arrow or right arrows and also backspace keys. Then you can execute that line too. Okay, now let me explain how SPEDAS works. Okay, so this is one of the simplest command line procedures that most users would use SPEDAS framework. Okay, first, of course, you have to run IDL and also initialize some environment variable or settings for SPEDAS on IDL. Then you have time range for which the data are loaded for your analysis. Then finally you can load the data for your analysis, and you can manipulate those loaded data arrays if necessary. Then finally you would plot those data. Then this kind of plot would appear on your screen. Okay, so let me show you actual command line here. Okay, first we have to type IDL here to run IDL itself. Okay, then you have to type ERG underscore init to initialize ideal environment for loading and also plotting ERG project data. Okay, so then in this example, we type this command here to set a time range for which the analyzed data is loaded here. Okay, with this command, we can set time range from May 27th, 2017 to June 3rd in the same year for 7-day period. Okay. Next, we have to put some command to download and also load satellite or project data here. Okay. Here, for example, we execute ERG underscore load MGF data, which is to load the magnetic field data obtained by MGF instrument on board the ERG satellite. Okay, now this command is downloading data files from our data repositories online through the internet, and those files are saved on your local hard drive on your PC. Okay, now data is loaded on ideal sessions, and some rule of the rows are shown here. Then, okay, it's all done. So you have the data now on an ideal session. Then, if you run this tplot command, then that gives you a plot of that gives you to the two plots over here. That's a magnetic field, 3 component of magnetic field data in DSI coordinates, and also magnetic field intensity for the same time interval. So this is the simplest procedures to use the SPEDAS for loading and plotting the ERG project data. Okay, and also you can use some variant of this time span command to set a specific time period for which data are loaded. So basic usage of this command time span is time span, comma, and time string, which means the start time of a time period, and some numbers and options. Okay, so if you put a /day at options, then this number means the number of date, and if you put /hour at this option here, then this number means number of hours from this start time. Okay, and you can just omit this, the length, the number of time lengths, and this option. You can just you can omit them. Then you can just write time span, comma, 2017 May 27th. That means 1 day period from start time of this May 27th, 2017. Okay, well, you can set a time and date range in more details by typing like this. For example, time span May 29th, 3:25:30 UT, and 90/min, which means 90 minutes period from this date and time. Okay, so in these ways you can set freely the time and date range, and you can load and plot for designated date and time period. And also you need to know the basic about tplot variables which is the primary data models used in this SPEDAS framework. For example, in the previous slide, we plotted some data variable named ERG MGF level 2 magnetic field 8-second DSI coordinate data. And if you have seen that this data variable is given as the ideal string, something like this, which is called tplot variable. This tplot variable is just ideal string on ideal, but behind the ideal session, this tplot variable is actually linked to some data structures and data rates on ideal memories, which contains the time series data with metadata, which describes the data themselves. For example, if you find some tplot variable on a SPEDAS session here, but these tplot variables on tplot variable on SPEDAS session is linked to the set of data arrays here, including time array and also data array, and also necessary metadata which describes these data too. So if you have two tplot variables on a SPEDAS session, that means you have the two set of data arrays on the ideal. Then you can manipulate or plot or load those data here. Okay, so once you type data load routines such as ERG load MGF, which we just used on 2 or 3 slides before, then if you type and execute this command, then this command tries to download the data file from our online repositories, which is provided by ERG Science Center. Okay, then corresponding data files, which is basically archived in CDF format. Those data files are downloaded through the internet and saved locally on your local hard drive or your PC right here. Then finally, ideal load this data file and read this data file as a tplot variable on your SPEDAS session. Because this is basically how the SPEDAS works to download and load data from remote repository. Okay, here. And for the sum of the ERG data, this 1 year latency rule is applied. Okay, so basically, scientific data of ERG satellite is opened to the public if it passed the 1 year after the observation time. But to access the data within that 1 year latency from the data acquisition time, say you would type working group password and ID to get them. So you have interested in, so you have so you would contact the PI of each instrument data or science center. And also to download the data, you have to know what data are included in this ERG satellite data. Okay, but if you learn general overview and also how ERG Science Center works for this data archive and SPEDAS framework from these 2 papers here. This is ERG project paper and also that paper specifically describing the ERG Science Center here. And also ERG satellite provide 1, 2, 3, 4, 5, 6, 7, 8, 9 instrument data, and basically, and some of those are listed on the right hand side here, and besides these orbit data and attitude data, other scientific instrument data is well described by each instrument papers as listed here. So please refer to those papers to learn about what these particular data contain, and also those data, what those data can do for you for your analysis.